I'm going to go over some review stuff, and then if you have time for homework questions, that would be perfect. Okay. So the first thing on the quiz is trig identities, which is just simplifying. It is not solving. So just a quick review. This is one that we already did. So while you're all pulling stuff out, you need your reference sheet. This says cosecant squared over 1 plus tangent squared. It's on worksheet 1B. It's probably already done on your notes. But what do you think when you see a 1 plus tangent squared, guys? I think there's a trade for it, yeah. So a 1 plus tangent squared is a secant. So we have a cosecant squared over a secant squared. Then if you wanted to change them to sine and cosine, this would be 1 over sine squared. And it is being divided by 1 over cosine squared. Now, be real careful. If you need to, write it sideways first so that you flip things over correctly. This becomes 1 over sine squared. The second one flips over, so it's cosine squared over 1. So then what do I get? Cosine squared over sine squared, which is? Okay. Questions on that one? All right, that was just a warm-up. Worksheet 5A has a few simple ones. Can you try those real quick? Cosine times secant. What's secant, guys? By the way, this is homework. This worksheet is on the homework check, so write these down. Cosine, what's secant? So it's 1 over cosine. So cosine times 1 over cosine would become 1. What about cotangent times sine? What do you want to do there? Cosine over sine times sine. Yes. 1 over secant. So it's 1 divided by 1 over cosine, which would flip to become 1 times cosine over 1. Any questions? Those are really basic ones. Number 4, any ideas on this one? Okay, that's a really bad idea. Do you remember killing kittens? Can we cancel anything that's glued together with those plus or minus? What can we do up top? Okay, so if we take out a cosine, then we'll have 1 minus cosine. It was cubed, so if we take 1 out, we'll have squared. Now what? Okay. Yes, both of those things are true. These are no longer being added or subtracted to anything. They're multiplied, so we can divide them out. And then Xavier said 1 minus cosine squared is a sine squared. It's a Pythagorean identity. Any questions? Okay. Number 5. Yes, again, this is a homework worksheet, so be doing these. Sine squared plus cosine squared? Yeah, we can replace these two. It says add. You can add in any order you want. If I add those two together, it becomes a 1. So then I have 1 plus cotangent squared over cosecant x. 1 plus cotangent squared. Anything out of that? Be careful. 1 plus cotangent squared is a cosecant squared, is that what you said? Yeah. Okay, I just couldn't. And what's a cosecant squared divided by a cosecant? Just a cosecant. 1 will cancel one of those out. Now, please notice that I did not start out by changing everything to sines and cosines, right? That's not always the best way to start. Look for your Pythagorean identities If that's not working, then try changing things to sines and cosines, or if sines and cosines isn't working, try something else. Don't give up. On 9B, there's one here that, anybody know what would happen here if I did this? What does it mean, secant over tangent quantity squared? Yes, it means secant squared over tangent squared. If you don't want to write this one down, just pay attention up here real quick. They have a common denominator, right? So then I can combine them. Now, secant squared minus 1 is a tangent squared. So then I end up with tangent squared over tangent squared, which is 1. All that mess became 1. All right. So that is the idea behind identities. The only other one I might throw on the video here real quick. This is not an identity. Well, no, that's not the one I wanted either. This is an identity question, but what do you have to do to be able to combine these, guys? You get a common denominator, okay? So you would multiply this one by secant minus 1 over secant minus 1, and you have to show that. And over here you would multiply by secant plus 1 over secant plus 1. Now, on the top, that means I have cosine times secant, I'm distributing through here, minus cosine. I know this is messy. And then I have a plus cosine times secant plus a cosine. And it's all over a secant minus 1 times a secant plus 1. What happens when I foil that bottom together, guys? Minus 1, right? The middle terms cancel out. If I multiply x plus 1 times x minus 1, I get x squared minus 1, right? Perfect squares. All right. So up top, I have a secant times cosine. What is secant? 1 over cosine. So what is cosine times 1 over cosine going to become? 1. Back here, I have another one of those. And then I had a minus cosine plus cosine, which is going to become 0. So I have a 1 plus a 1, which is a 2. What's a secant squared minus 1? Secant squared minus 1 is a tangent squared. And you could leave it like this. Anybody know what else that would be equivalent to? Yeah, 1 over tangent is cotangent. So you could say 2 cotangent squared. All right, I lost theta or x a long time ago, but that was a homework question. I was just reviewing one where you had to get a common denominator because there is one on the quiz, or I think. Okay, back to the review. On to 5.2, which is verifying identities. These are sometimes considered easier because you know where you're trying to go, right? So worksheet 8A, can you grab 8A real quick? Well, actually, I didn't star either of those. Just kidding. 8A number 7. Yes, 8A number 7. How would we be able to deal with this one? By the way, Miss Abruzzo said this one has a typo. How would we deal with this? 1 minus sine squared over 1 plus cosine. Change what? You could and then factor it or something. Okay. I was thinking we should get a common denominator. Can we try that? What would this 1 become? we're multiplying, right? So 1 times 1 plus cosine would just be 1 plus cosine. And then there was a minus sine squared up there. And our common denominator was 1 plus cosine. Now what? Can't cancel anything. That's the most important thing. Xavier, you're pretty good at looking for these. What is a 1 minus sine squared, guys? It's a cosine squared, right? So then I have a cosine plus a cosine squared all over a 1 plus cosine. I just changed from x's to thetas. Oh well. What? We still can't cancel anything. We can take a cosine out of the top. And remember, this was a proof, so I have to show all these steps. I'm not showing them in a nice linear fashion like I should be. I don't know if I can move this. Oh, I can. What do you know? All right, I can take a cosine out of the top, x or theta, whatever. It used to be an x. So I would have 1 plus cosine. I can't do it. So now what? Now this quantity can divide out, and I can say this equals the right-hand side from way back up here. Right here. Okay? So that's an identity, when you make one side equal the other, and you can only change one side. The minute you start changing two sides, it's a concept error. All right. 8B has some more of those. 9B. Let's try 9B. Number 13 on 9B. What would you do? Which side would you like to work with here? Left. Okay, what do you want to make cosecant? Because there's no squareds, I'm thinking we need to just start trading, right? 1 over sine minus cosine times, what do you want to make cotangent? Oh, I think we're in luck. What happens? Well, I get 1 minus cosine squared. This is over a sine, and this is over a sine. Already, we have a common denominator, right? So we get 1 minus cosine squared. And what is a 1 minus cosine squared? Okay, so this is a Pythagorean identity. We can trade it for a sine squared over a sine, and then one of those will divide out. So we just get sine of x equals the right-hand side from up above, way up there, even higher than my little squiggle goes. Right up here. Okay, that was a worthy of the quiz kind of question. I don't know if I have any more identity practice or not here. I do not. Does anybody have a homework question off either? I do. Look. Is this a homework question? They had 5.2 assignment. 5.2 number 8 was not assigned? Okay. Well, I must have just thought it looked good then. Can I do it real fast? For quiz review, what would the common denominator be here? Yeah, so this one would need to multiply by sine over sine. And this one would need to multiply by 1 minus cosine. I have no room. Okay, since it's a verify, you would be expected to show all the steps, so I will do that. Sine over sine times sine over 1 minus cosine. And yes, I'm leaving out my thetas. This one had a 1 minus cosine over sine, and I would multiply by a 1 minus cosine over a 1 minus cosine. So what's my common denominator now? Sine times 1 minus cosine. But what happens here? And And back here, can you FOIL that together, guys? 1 plus a cosine squared, right, is true. But there's 2 cosines there, right? A minus cosine and a minus cosine, whatever order we did that in. Are you good if we're FOILing it all together? Anybody lost where those came from? Okay, now what happened up top? Anything good? What is a sine squared plus a cosine squared? That's a Pythagorean identity. So we have a 1 plus there was another 1, and those could be minus 2 cosine. Okay, so that adds up to a 2. Now what? Take out a 2. So we have 2 over sine. 2 times 1 over sine becomes what? So 2 cosecant? Is that what we were supposed to get on the right-hand side? Everybody good? What's an identity, okay?
We don't put like equals right on the left-hand side, would you take points off?
No. Just so that what you get is equivalent to what it said you had to get. Yeah, no, I'm not crazy picky on the formatting. I just have to be able to follow your steps, okay? If you do something and it works, but I can't tell where it came from the step above, then there's going to be a problem. So I'd rather you put extra steps than not. All right, did anybody have a homework question off 5.1 or 5.2? No? Okay. Then I'm going to move on to 5.3. This is just a practice question. It says solve this equation for all values of x. Does anybody remember what we need to do here? We just need to what? I think this is off worksheet 3B. So I think we probably already did it. But can anybody glancing up here tell me what we might have done? Actually we could. We could make it equal to 0. And then it would factor. And that might have been a better plan than what I was going to say, because you might remember to get, if you just square root, what do you have to remember? That's my big concern for the quiz, because there's a question on there that talks about this. When you square root, you get tan of x, but you have to remember what? Okay. So if it says, what are the values of x for which the tangent is 1? So look at your unit circle. Tangent is tricky. Anybody remember where we find the tangent is 1? Yes, square root of 2 over 2. So that is at pi over 4. And the other place that it would be -1 or +1 in every quadrant at that spot, right? So we'd have pi over 4 and what else? Now, it says all, so what does all remind us we have to do? Plus or minus 2 pi n. Normally, it's a tangent graph. You could put, if you listed all those, you could put 2 pi n and you'd be good. But if I could say the period is pi. And actually, if I write pi over 4 plus pi, do I also have to include 5 pi over 4? You can, it wouldn't be wrong, okay? But this is like the minimum, or you could write, there's other ways. I'm just gonna stop now. Yeah, long ways, okay. All right. Worksheet 5, again, I'm on. And remember, this is a homework assignment, so let's talk about this. There is one on the quiz where we have a reciprocal function. It does say for all values of x. In radians, it should be okay. So cosecant is -2, means 1 over sine is -2 over 1. So what do we do then? You could cross multiply and divide, but you want to get the sign by itself, so the sign would equal what? Guys, this should make sense from here to here. Cosecant flipped over is sine, -2 flipped over is -1/2. Are we good? You don't have to show me any crazy work. But now you got to figure out where on the unit circle that's true. The sign is the y value, so -1/2, I'm thinking, remember to draw these little things on your quiz. It will help me know that you were in the right spot, or not.
Can I ask,
Yes,
when do we know that we have to use the negative pi 6 and stuff like that?
that was when we were doing inverse functions. Yes, when we were doing like, this one, remember? Okay, and it wouldn't be wrong if you used those here. As long as it says all solutions, you can use the negative name and it wouldn't matter. If it says between 0 and 2 pi, then you have to use the positive ones. Okay, so I'm thinking that's 7 pi over 6 and 11 pi over 6. Did I do that right, or do I have my, okay. And then if it's all, I have to put a 2 pi n on the back. So remember the reciprocal ones, you're just flipping it over. Let's practice a tangent one more time. I don't know if there's one on the quiz. Here you would divide by 3, right? Okay, tangent is hard. The tangent is negative down here. But basically, I have, somewhere I have a square root of 3 and a -1/2, and I have a 1/2 and a negative square root of 3 over 2. I know it's one or the other of those. Which one of those is going to give me the tangent that's negative square root of 3 over 3?
Negative 1/2.
One with -1/2. One above.
Okay, this one, when I put the y over x, I get negative square root of 3 over 1. That's not it, right? Make sure you're doing y over x. So this one would be 1 over square root of 3, which would rationalize to this. So it was this spot right here, which is a negative pi over 6 or a 11 pi over 6. Now there's another place, but it should be where? Straight across, right? Because it's tangent. So you could just write plus or minus pi n, or you could list the other one, which was 5 pi over 6. And you could put 2 pi n, as long as you listed both of them, it wouldn't be wrong. All right, moving on. Now I'm on 5b. Equation solving. Oh, look at the directions though. What does this say? Only between 0 and 2 pi, right? Okay, number 17, ideas? I don't think we want to divide by 4. Number 17, guys. That sounds like a plan. So 4 sine t minus 2 sine t is 2 sine t. Minus square root of 3 equals 0. Now what? Add the square root of 3 over to the other side. I'm just going to cross this one out. So I have 2 sine t equals square root of 3. And then divide by 2. Okay, now where on the unit circle is the sign square root of 3 over 2? The sign is? Okay, I was thinking it was pi over 3 and 2 pi over 3. Okay. Oh, number 20 is tricky, I think. What's happening on 20? If I isolate cotangent of t, it will say what? Add the 1 over to the other side and then divide by square root of 3. I kind of skipped steps. Are we okay? So if I flip that over and get tangent, I'll have what? square root of 3 over 1. I'm just going to leave it because I'm looking for that, right? I'm looking for where the y is the square root of 3 and the x is the 1. Yeah, that would be up here at pi over 3, right? I didn't draw it very well. Where else, though? Yes. What is it?
4 pi over
4 pi over 3. Because it has to be two negatives to make a positive. Okay, I don't know that there's a tangent one on the quiz even, so I probably shouldn't be stressing those. Okay, 25, 26, 27 down at the bottom, guys. These are definitely on the quiz. What can we do on 25? Take out a sign. What will it say after we take out a sign? Okay, so then I will have the sine of x equals 0. If I set this all equal to 0, I'll have the cosine of x equals, I don't have a lot of room, so can you do that? Subtract the 1 over and then divide by 2. Everybody okay? Would be getting negative 1/2. All right, this particular problem says from 0 to 2 pi, but there's a lot of answers, I think. The sine is 0. When y is 0 would be here and over here, right? 0 and pi. Is that right? Okay, be real careful because there's a parenthesis at 2 pi. I can't call it 2 pi. Everybody good? I got a bracket at 0. I can call it 0, but I can't call it 2 pi. Can't include 2 pi. All right, the cosine is negative 1/2. I'm thinking here and here. Is that where the cosine is negative 1/2? So that is at 2 pi over 3 and 4 pi over 3. How did I do? Does that seem okay? Okay, I don't even have my calculator on, but is this one you could graph to determine if it had 4 solutions? Y equals, okay, someone tell me what the original question said. Sine x, close parenthesis, then what did it say? Plus 2 sine x times cosine x. Radians, window 0 to 2 pi. I have 1, 2, 3, 4, and then it would be back at 2 pi. Everybody good? We got 4 solutions? Okay. All right. I just want to talk about 26 because everybody sees 26 and they think they should FOIL it together. It's already factored, right? Everybody see what I'm talking about? Don't FOIL number 26 together. I don't know that there's one like that on the quiz. But you'd have the cosine of x equals negative square root of 3 over 2, and the cosine of x equals negative 1/2. And then you just look for them on the unit circle. 4 answers. All right, but let's move down and talk about 27. What's happening in 27 right here? 2 sine squared minus sine minus 1. Okay, but instead of sine, I wrote m for a minute here. What do? I need a negative 1 at the back, so I need this one to be negative, right? To get a negative 1 in the middle. Is that factored correctly? 2m times m is 2m squared. Negative 2m plus 1m is negative 1m, negative 1. Okay. So I need to go back and put in what instead of m though? So it's 2 sine plus 1 and sine minus 1. So then sine of x equals -1/2 or 1. So where on the unit circle is the sign -1/2? 7 pi over 6. And 11 pi over 6, do I have that right? Somebody checking me? Sign -1/2? Okay, the sign is 0 means that I went up and down none, so I would be, oh, the sign is 1, I'm sorry. It doesn't say 0, it says 1. The sign is 1 at
Pi over 2 and,
pi over 2 only, right?
yeah.
Because it's, all right, and what if it had said all solutions? Plus or minus 2 pi n on the back of all those. All right, how we feeling about 5.2? Okay, then we get to yesterday's stuff. 5.3. Oh, no, we don't. Grab your calculator. On the back of the review, number 11 and 12 are graphing questions. Okay, number 11 and 12 are graphing questions. So your calculator should be in radians, set to 0 to 2 pi. The first one says cosine plus cosecant equals 2 plus sine. So you type into one of your equations here.
That's only these all.
Yes, you got to use your calculator because I want decimal answers. Cosine, you got to put the x in there. Plus, it says cosecant, so how do I type cosecant? It's not second anything, it's 1 divided by. What was it? It was cosecant, so it's 1 divided by sine, right? And then the other side says 2 plus sine. Okay, you graph them, make sure your window is set 0 to 2 pi. Now what? Window 0 to 2 pi. Your y value, not as important. You could have -10 to 10. I have -4 to 4 and it's working. Anybody need help? 2 plus sine. Everybody getting this? And how do I find the answers? Intersect, but what do I write down after I find the intersection? Only the x values. Okay, you have to get close on the guesses on these or it doesn't work like I just did. Well, what does it say? 4? Enter, enter. Okay. So I got this one. And anybody get those two? So it would be actually 2.830, right? You round? Like it says to? And the other one is 0.608. All right, can I be done with just one of those graphing ones? Okay. You can practice number 12. Hopefully the answers are the answers at the bottom? Yes? Oh, the answers are in Google Classroom, okay? So you can finish this for practice tonight. All right. This is worksheet 9 again, guys. I'm just going over this one more time because if you divided here and then you square rooted, what do you have to remember? Plus or minus. And what is the square root of 1? 1. And so you have 1 over square root of 2. Then what happens? Yeah, so you would be looking for how many places on the unit circle? 4, right? Okay, be careful. All right, I think we can go back and talk about the second kind now. Okay, here's a starred one. Apparently I didn't star any of those, okay. This is from worksheet 5B. What would you do first here? 29. Two cosine squared plus 11 cosine plus 5 equals 0. Good? Now, how do I factor 2n squared plus 11n plus 5? 2 and 1, 5 and 1. I think that's the order I would need so that I get 10 and 1 is 11 in the middle. So 2 cosine of x plus 1 and cosine of x plus 5. Okay, cosine of x is negative 1/2 or negative 5. This one is void, yes? Does not work. Cosine or sine can never be more than 1 or less than negative 1. All right? Where's the cosine negative 1/2? X value of negative 1/2. I'm thinking at 2 pi over 3 and 4 pi over 3. What are the directions for 29 on that worksheet?
So for x within 1 and 0 and 2 pi.
Okay.
Exact solution.
So that would be it. If it said all, then we'd have to remember plus or minus 2 pi n, plus or minus 2 pi n. Questions? All right, the kind we have not yet talked about. Turn to the back of your review and look at number, I'm going to start with 8. Okay? What is going on here, guys? What do you got to notice right away? The 4 is inside here. This is a U substitution problem that we learn yesterday. So you ignore that 4 for a minute and you say 4 theta, whatever it is, call it U if you want, is, where's the sign negative 1/2? So the sign is negative 1/2. It's what? 11 pi over 6 and plus or minus 2 pi n. Don't forget that. Because now what do we have to do? We have to divide everything by 4 or take 1/4 of everything. So we're going to take everything in here and take 1/4 of it. So 1/4 of 4 theta will just be theta, which is what we're trying to find. 1/4 of this will become what? 11 pi over 24. Beautiful. And 1/4 of this, 2 pi over 4 becomes pi over 2n. Okay. And down here, when we take 1/4, we get 7 pi over 24 plus or minus 2 pi over 4 or pi over 2. Now, I want you to think for a minute. What did that sine of 4 theta look like? Here's a regular sine that finished by 2 pi. When you graphed the sine of 4 theta, the period was 2 pi divided by 4 or pi over 2. It finished a whole cycle by pi over 2. So it went, okay? That's what it looked like. I don't really care what it looked like. What I care is that it was repeating every pi over 2. Does that make sense with our answer here? That we're saying it's repeating every pi over 2. All right. One more of those. You want to try a tangent? Or you want to do one with a fraction? I don't think there's a tangent one on the quiz. Or you want to do a homework question?
Number 3 on book 331.
I don't think so, but let me look at what it is. Page 331. What assignment is that? 5 point?
5.3.
Okay, so it is something on 5.3, so it's a good question. Come on, bookwork on 5.3, there we go. Oh, that was 5.2, darn it. I clicked on the wrong one. There we go. Okay, so tell me what number? Number 3. If you subtract 1 from both sides, this will become 1. If you divide by 4, you'll have 1/4 equals cosine squared. If you take the square root, you have to remember plus or minus. The square root of 1 is 1. The square root of 4 is 2. Whoops, I just square rooted that, so it's just cosine. So there are 4 places on the unit circle where the cosine is either positive or negative 1/2, and then it says all solutions. Do you need me to keep going?
No.
Okay. I don't know if the bookwork had any U substitution questions. I feel like it didn't. What about worksheet? Here's some more U substitutions. You want me to do this one real quick before I stop the video? Here's one with a 3 in it. Where is the sign square root of 2 over 2, guys? Okay. The sign is square root of 2 over 2 at pi over 4. And it is also at 3 pi over 4. The sign is positive, square root of 2 over 2, yes? Okay. But U is really what? No. U is really 3x. Okay? So now I have to do what? Take a third of everything. 1/3, 1/3. So it will say x equals pi over 12 plus or minus 2 pi over 3n. And this one, when I take 1/3 over 12, what's 3/12 though? Okay? So there's another example of a U substitution. Questions? Any other homework questions?